10.4, and we're talking about some more rules. So basically, this is just a big square root section. Like, how do we add, subtract, and multiply square roots? Basically, just diving into the rules for dealing with roots. So you remember this. So first off, how are we going to simplify those things? What are we going to do?
Dividing.
What's in the hooks there? I don't see anything in the hook. What does that mean in the hook when there's nothing showing?
Square. It's a square.
Yeah, there must be invisible twos, right? When there's nothing in the hooks, they're called a square root, two root. Which means what? So what? Who cares? What does that mean to me? What am I going to do about that? When I break down the 75, I'm going to ship out 2 for 1, aren't I? That's the significance, the meaning of the 2. So you choose your calculator. Maybe you have a new fancy calculator. Maybe not.
95 times 5.
Break things down. Like Karina's got one here that's really nice. Break one down. So 3 times 25, 5, 5. So the guts of a 75 are 3, 5, 5. You know what I mean? 75 is 3 times 5 times 5. And then break down the 147. I know that's, I don't look at 147 and know everything. I just try things on my calculator. So I just try dividing by 3. I know 2 doesn't go in, right? Doesn't end even. So just try dividing by 3, and you get,
49.
Thank you, 49, and then that one, 7 times 7. So the 147 is 3 times 7 times 7. Good so far? I'm just breaking down the numbers. So now remember, the number in the hook is like the deal at the store. 2 for 1. Right? There's invisible 2s in the hooks here. So that means the deal is 2 for 1. So 2 5s in, 1 5 out. And they're both gone. So this one becomes 5 root 3. Good so far? Remember what I'm talking about with the roots? You get in the hang of the way roots work? So it's 2 for 1. 2 5s in, right? It's like 2 5s in the store. You go out of the store paying for 1s. 2 for 1 deal. They're gone. They're out of the store. Next one, same thing with the 7s, right? 2 for 1. 2 7s in, 1 7 out. They're gone. 7 root 3. Now they're all simplified. Now how can we simplify that further? What do you do with 5 root 3 minus 7 root 3? You know what it's like? This will not be hard for you if you just think about x's. Roots are just like x's. What would you do with 5x minus 7x?
Put them together?
Yeah, and it'd make what?
2.
Negative 2x, right. Right, because 5 take away 7 is negative 2, and then you just keep the x. That's exactly what you do with the roots. So what's it going to be? 5 root 3 minus 7 root 3? Exactly, you got it. Yeah, the rules for roots are just like for x's. So, just like for x's. So you just do the numbers in the front. You don't mess around at all with the roots. Just like that. Good? Questions on that one? Everything good there? No questions? All right. Let's try number 2. Number 2, same kind of thing. 2 root 48. 2 root 48 minus 3 root 32 plus root 27. Yeah. Okay. So let's try that one. Let me give you. So here we go. Break down that 48. 6 times 8. Break down the 6. 2 times 3. 2 times 4. 2 times 2. So there's all the little pieces in the 48, right? 2, 3, 2, 2, 2. We good? So, what's coming out? Got 2 2s here and 2 2s there. So 1 2 from that pair and 1 2 from that pair. Is that okay if I just do it that way rather than rewrite it all? Is that too confusing? I can rewrite it.
1 2 3 4. That's 8. No, that's the 8 outside.
Because the 2 in the front is a whole number, right?
Right. It's a whole number 2, so it's going to be 8 in the front. Yeah, you guys okay with that? I'll just go back to that. Yeah, these 2 2s send a 2 to the front. These 2 2s send a 2 to the front. So 2 times 2 is 4 times 2 is 8 in the front. What's left in the root?
3.
That 3, huh?
Under the root.
Yeah. That good so far?
Yeah.
And now do the 1 in the middle. The root 32. 4 times 8. 2 times 2. 2 times 4. 2 times 2. So all those little pieces. 2 for 1. 2 for 1 deal, right? So 2 2's in is going to ship 1 2 out. It's going to multiply. And these 2 2's are going to ship another 2 out. And they're going to multiply what's already in front of the root.
Minus 12.
So it's going to be minus 12. What's left in the root?
2.
Yeah, this 2. One of the 2's. Like this 3 was left. Let me slow down there for a minute. Is that? Let's break down the 27. 3 times 9, and 9 is 3 times 3. So what happens there?
3 goes out.
Yeah, there's nothing already in front right here, is there? So there's nothing going to be multiplied in the front. So 2 3's come to the front, and the other 3 is left inside. We good there? All is well to that point, so they're all simplified. Now, what are we going to do from here?
Add similar.
Yeah, like terms. Exactly. Yeah, you know what? This guy and this guy are like terms, aren't they? It's just like if you had 8x and then 12y and 3x. You know what I mean? It's like those two are the same letters, kind of like. They're the same roots. You get what I'm saying on that? So same roots are just like same letters. Like roots, like letters. Different roots are different letters. So it's exactly the same rules. It's just like terms. You can add like terms with like terms. So like roots with like roots. So yeah, we will just say 8 root 3 and 3 root 3. That makes 11 root 3, doesn't it? And then just bring down the 12 root 2, and that's it. They just have to stay separate because they're unlike. And we're done. How we doing? So these two here were like roots. So like roots, you just add the numbers in the front. Keep the root unchanged. Questions I can answer? All right. Okay, so same kind of thing. So now we have letters in the mix, but it's really the same game. So just break down that 100, break down that 49, break down that 64. Oh, actually, that's pretty easy, huh? We can just do the square root straight, huh? We don't need to play a bunch of games. What's the square root of 100? 10. What's the square root of 49? 7. What's the square root of 64? 8, right? We just know those, don't we? If you want to write, 10, 10, you could do the same thing. The same rule still works. 2 10's in, 1 10 out. You might say, hey, but shouldn't we break that 10 down? There's no rule that says you have to. As soon as you see a matching pair, 2 things, you don't have to keep going further. Usually we need to find a pair. But if you can find a pair right away, great. 2 10's in, 1 10 out. Now, how about the letters? Or just say square root of 100 is 10. You know that one, right? Now, what about the B's? Well, there's 3 B's. So who's coming out? Yeah, 2 B's in will ship 1 out, and the other one is left in, huh? Does that make sense? It's the 2 for 1 deal, isn't it? 2 B's in, 1 B out, the other one's left in. Now go to the middle. Square root of 49 is 7. 3 B's in, what's going to happen?
B out.
Yeah, same thing. 2 B's in, sends 1 B out, the other's left in. And finally, square root of 64 is 8. Again, 3 B's in, 2 in makes 1 out, and the other is left in. Are we good to there? Now, the question is, are these three like terms? Are their letter and root parts identical? Yes, aren't they, right? B square root of B. That's all part of his, like his name, his type. B root B. And so 10 B root B's plus 7 B root B's minus 8 B root B's. They're all like terms. They're all exactly the same letter pattern. Their letter patterns are identical. They're like terms. So you got 10 of those things plus 7 of those things minus 8 of those things. 9 of those B root B things were done. Root rules aren't too bad, are they? They just get a little messy at times, but the rules are pretty real. Well, there's two straightforward rules: the ship out rule and the like terms rule. Just follow those, and you're pretty safe. But they will get ugly a little bit, and they're going to start putting other numbers in the hooks. They get a little messier. Good to there? Okay. So take careful examination with me. Before we dive in, let's make sure we're seeing everything that's there. Over the years, I've noticed how much little things will escape people's notice, and then it'll really mess you up. So notice, first off, what's in the hooks here? 3 in the hooks, right? 3's in the hooks, so we're going to have to, everything's going to be a 3-for-1 deal on this one, right? 3 in, 1 out. So 3-for-1 deal of sort. Now, most people see that, no problem. Here's what I've noticed most people don't notice. The first fraction is the root, the cube root, the 3 root. Is it over just the top or the whole fraction? The whole fraction. So I'm going to put that on the top and the bottom for extra clarity. How about the second fraction? Is it over just the top or the whole thing?
Just the top.
Is that better? Oh, yeah. I should be doing that all semester. All right, yeah, just the top on the second one, huh? Is that okay with you, Erica? You keep front row C?
Okay, yes.
All right. So, cube root of 5. So, for extra clarity, I'm going to go ahead and just put it on both. You don't have to. It means that anyway. But I found, people get messed up sometimes. So, for extra clarity, I'm going to be like that. So, look, it's on both top and bottom for the first one, but only the top for the second one, right? Not really matters. Okay. So, now, on the top there, cube root of 5 on the top, there's nothing we can do, right? There's not 3 of anything. There's just a 5. Forget about it. There's nothing you can really do up there. But how about the bottom? We can break that 64 down. So let's do it. Let's break down that 64. So just take your calculator. I'm thinking 8 times 8. But there's a million. You can go 2 times 32. You can do whatever you want. So then break down the 8. What times what is 8? 2 times 4. 2 times 2. And the other 8, same thing. 2 times 4. 2 times 2. So I broke down that cube root of 64 all the way to 6 2's. So yeah, what's coming out then? Remember, it's a 3-for-1 deal, right? So 3 2's here, send 1 2 out, and 3 2's here. Send 1 2 out. They multiply. And what's left over in the root?
4.
Nothing. Remember, you might say, well, yeah, what about that 4? He broke down. See how he's got arrows? I mean, he's not still there. We broke him apart. We're just talking about the final ends of the tree. The leaves, they call them, right? The ends of the trees. So yeah, we're just talking about the final things. So there's nothing left. So this becomes cube root of 5 over 4 minus cube root of 5 over 5. Everybody see what happened? This first one changed. The second one hasn't changed at all. That good so far? Now, we're done. The root work is over. There's nothing more to do with the roots. We got everything out. That's all good. Now we just want to subtract 2 fractions that have different denominators. How do you subtract 2 fractions that have different denominators?
You multiply?
Multiply to make the bottoms the same, right? Common denominator?
20.
So multiply by each other, going to be 20. Exactly. So, yeah. So multiply top and bottom of this one by 5. Top and bottom of this one by 4. To make them both 20. on the bottom. So this will be 5 cube root 5 over 20 minus 4 cube root 5 over 20. So this isn't the roots, right? I'm not going in the, this is just outside the root stuff. And so now can I subtract those?
Yes.
For sure. They're like roots, aren't they? Look at that top. We have 5 cube roots of 5 minus 4 cube roots of 5. What is that?
So it's a 1.
1 cube root of 5 over the common number of 20. And that 1's optional. You don't really need the 1, right? That's the same thing as just cube root 5 over 20, isn't it? The 1 times anything is just itself. So there we go. So what did we do? We just did the same thing we're always doing. We broke down the 64. We did a 3 for 1. 3 for 1. Shipped out because there's a 3 in the hook. The root vanished here, huh? Because there's nothing left in the root. There's nothing left in the root. Poof, it's gone. And then we've got common denominator. All right. Okay. So, what's in the hooks here? I don't know if you can tell if I wrote it very neatly, but this 5 is not in the hook. That's just a big 5. So that's 2, right? There's nothing in the hook, which means there's an invisible 2 in all those hooks. So it's a 2 for 1 deal. So, okay, so what's going to happen then? Well, is it okay? Can I skip some steps here? Would that be okay? Let's see. If you were going to the store and there was 11 items, 8 and 11th, right? And they were on sale 2 for 1. There'd be 5 coming out, wouldn't there?
Can't you do like
Basically, yeah. What you can do, because you got to make it even, don't you? You got, well, I mean, I guess you could do a lot of things. There's A to the 10th and 1 more A. There's B to the 6th and 1 more B. How about that? Is that helpful? Right? So the A to the 11th is 10 A's and 1 more. I'm just showing clearly that that's 10 A's and 1 more A. So what? Well, that means those 10 A's are going to ship out A to the 5th, right? And they're gone. Because for those 10, you'll pay 2 for 1. You'll pay for 5. The extra 1 will remain inside, won't it? How about the B's? These 6 B's. So you see what I did? I broke it down, those odd powers. I made it even and 1 more. So the B to the 6th,
B to the 3?
B to the 3rd out, gone. So with 1 extra B left inside, huh? So what's going to be in the front then? 5, A to the 5th, B to the 3rd. What's left inside?
A1 and B1.
Yeah, AB. Square root of AB. Is that good for that first one? Did you all see what happened there? Want to try the middle one? So A to the 9th is A to the 8th. So whenever they give me an odd power like that, I'm going to do an even with 1 more. And B to the 5th is B to the 4th and 1 more, huh? So now we're going to do the ship out thing. So A to the 8th will ship out A to the 4th, and they're gone. But that's going to hit the other A that's already out there. Right? When there's already stuff in the front, whatever comes out hits that. And so that'll be A to the 5th in the front. Does that make sense? And then the B to the 4th. We'll send out B squared, but that'll hit the B that's already out front.
B to the Q.
B to the 3rd, huh? Yeah. And then what about square root of 4?
2.
That's just 2. Just pop a 2 in the front, huh? That comes out, right? Because that's 2 2's. 1 comes out. What's left inside the root? Yeah, the leftover A and the leftover B, huh? So you just got to be careful. I think you know the rules. It's just about being careful with tracking with everything. Did you get the third one? So get this other one over here. Same kind of thing. Ship out what you can. So there's just one a, so that's not doing anything. What do you do with b to the 7th? B to the 6th and one more, and then that b6's sends out b to the 3rd, and they're gone, huh? And then the square root of 36, what's that?
36.
That's just 6. A to the 5th is already out there. B to the 3rd goes out there. What's left inside? A, B again. This left over A. This left over B. All right, look at those terms that we've got now. Do you notice what's going on? They're all like, aren't they? They're all a to the 5th b cubed root ab, a to the 5th b cubed root ab, a to the 5th b cubed root ab. They're like terms. So 5 of those things minus 2 of those things is 3, plus 6 more of those things is 9 of those a to the 5th b cubed root ab kind of terms. Just add the numbers in front, right? With like terms, you just add and subtract the numbers in the front. 5 minus 2 is 3, plus 6 is 9. How we doing? Questions I can answer?
Well, you know how like the 36, it's 6, but, you know, like if you wanted to break down the 6, how do you?
Yeah, so good question, Karina. So on that 36, so Karina was saying the square root of 36 is just 6, which is what we got here, right? 6. But what if you broke it down and did 6, 6? Well, actually, I would write then ship. You don't have to keep going down, but I'll show you it'll work also.
Okay.
Both are right. But the quick thing would be go, look, I got 2 6s right now. Ship it up. Yeah, but it breaks out. Well, who cares? I only keep breaking down when I don't see a matching pair.
Oh, because I still.
If I see a matching pair, it's two 6s, 1 out. Yeah.
Right, and 2 times 3.
Yeah, so, yeah. No, yeah, if you want to keep going, it's okay. 2 3 2 3. But then what do you get? 2 2s? Out comes the 2. 2 3s. Out comes the 3. 2 times 3. Same answer. Math always works. Isn't that beautiful? But the quicker way is just to go 2 6s. Boom. Out comes, yes. You don't, as soon as you see a pair, ship out right then. You don't have to, you only keep going, keep breaking down if you haven't found matching pairs. Does that make sense? If you find a matching pair, ship it out right then. Or if you just know, square root of 36 is 6. Then just do that. But it'll work however you do it. All right, now notice what's in the hooks. 3, right? Those 3s are in the hooks. So 3 for 1 deal. It's always 3 in, 1 out on this problem. Use your calculator, break those down. Okay, I'm going to jump in and help. So 256, I don't know. 2, is it 2 times 128? 2, 4, yeah. And then this is going to be 2 times, I just keep dividing by 2, then I get 8 times 8. 2 times 4, 2, 2. 2 times 4, 2, 2. Now, it's really important you don't lose any of those 2s. How many 2s do we have altogether?
8.
8 of them, right. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8 2s. So I could just erase that now. So okay, if I just erase that and go, that's 2 to the 8th. So I'm going to go back up and just go, all right. And I'll just say, look, that 256 is 2 to the 8th. Now, 500. Well, let's finish it up. Let's finish up the first one. Okay. So now, what's going to come out? Well, maybe I should actually show the 8 2s. Probably better. 1, 2, 3, 4, 5, 6, 7, 8. So 8 2s.
You circle 3. So
Yeah, you circle 3 at a time because a 3 for 1 deal, right? So 3 2s in, 1 2 out, and same thing here. 3 2s in, 1 2 out. They're going to multiply on the outside. So 2 times 2 on the outside? 4. Okay, now what about the x's and y's? 3 y's in, 1 y out. Remember, it's a 3 for 1 deal for letters and numbers. 1 y out, and these are gone. Right? Out comes a y. So cube root, don't forget, anything left over, you got to keep it in a third root. What's left over? What's staying in? The x and the two 2's. 2 times 2 makes 4, and the x stays in also. We good? With that first one? Now let's go to the middle one. So if you break down the 500, 5 times 100, 10 times 10. 10 is 2 times 5. 10 is 2 times 5. So I broke down the 500. It's 5, 2, 5, 2, 5. So in other words, it's 2 2's and 3 5's. Good so far? So I'm going to erase that if that's okay, and just say it's 2 2's and 3 5's. 2 2's and 3 5's. So 2 2's, 3 5's. Now what's the ship out deal?
3 5's.
Yeah, 3 5's in, 1 5 out. Now there's already something out there waiting.
No, you times.
It times it, right? It was multiplying inside. They're going to multiply outside. It's all been multiplying so far, hasn't it? It's going to multiply on the outside, so that'll be 40. What about the letters? Y cubed in, 1y out. What? And then cube root of, what's left over in the root?
X.
2 2's, 4, and the x. Huh? Finally, the 108. I have no idea what's in 108. Let me try it. 2 times 54, that's 6 times 9. 2 times 3, 3 times 3. All right. 2 2's, 3 3's. The breakdown of 108. 2 2's, 3 3's. So, I can erase that then and summarize it. 2 2's and 3 3's. 2 2's and 3 3's and an x. All right, so you know the deal, right? So 3 2's, or 3 3's in, 1 3 out. They're gone. And there's a y already out there, huh? So it'll be 3 and y on the outside. And what's left on the inside?
4 inside, 4x.
4x, just like the other ones, huh? All right. Look at all that. So are they like terms? Again, they are. They won't always be, but they often are. Y cubed root of 4x, y cubed root of 4x, y cubed root of 4x. The letter patterns match identically. So just add and subtract the numbers in the front. In this case, add. So 4 and 40 is 44 and 3 more. 47. Y cubed root of 4x. I'm not writing that very neatly here. 47y.
Okay. You break it down, and then the numbers you can break it no more. You put it online, and then you start making groups, right? Like a packages.
Yeah, right, right.
Because I get kind of confused when I go break it down.
Right.
So you break it down, like I say, a number under 9. A number under 9.
Right.
Those packages that you find.
Right.
Is that you summarize, like you say, times.
Yeah, I think it's easy to summarize. Yeah, I think it's helpful. Just clean it up that way. Yeah. Is that what you're saying? Yeah, I wrote it with summarizing with the times. Yeah.
Yes, because I get lost when I break it down.
Yeah, when you have the big old tree thing, it can be kind of confusing, huh? So make sure you notice how I underline all the ends, like when I broke down the the 500, and I said it was 5 times 100, 10, 10, 2, 5, 2, 5. And then I underline all the ones that didn't break down further, right? Like I didn't underline the 10, he broke down further. But all the bottoms, all the ones that didn't go down anymore. And then I went, okay, what do I got? 3 5's, 2 2's, and then I just put it up here as a summary.
And then summary, and then make groups.
And then do the groups. Exactly. Yeah, so just be careful with the trees not to lose anything. And there's a big hint sometimes. When they start coming out all the same, if you get one that's not the same, double check. You might have messed up. See how they're kind of coming out the same letter pattern? So they won't always do that, but they often do that.
I was looking at YouTube say something about like factoring. Like what? Factoring? Like
maybe that's another one we'll look at. Yeah. Questions on that one? We good? So try that one. Notice with that first fraction that the cube root is over the entire fraction, huh? But on the second one, it's just on the top, not on the bottom. Right? So I would rewrite that first one and just make it 2 roots. I just found it's easier for students over the years. So make it cube root 16 over cube root 27, because that's what it really is, right? That first one is really a root on both. So I'm breaking down that 16. 3 2's inside. Since 1 2 outside, the leftover 2 stays in. Good for the 16. And then the 27. 3 times 9 is 27. 3 times 3. So there's 3 3's in. Sends 1 3 out, and that's in the denominator, so it stays in the denominator, right? And there's no more root, huh? Because there's nothing left over in the root of the 27. The root vanishes when there's nothing left in it. You've seen that before. Getting the hang of that? And now for the 54. 6 times 9, 2 times 3, 3 times 3. So there we go. 3 3's in, 1 3 out, and that leftover 2 stays in. That good? And now what do we do? Yeah, you got to get, so now to subtract those, we got to make the bottoms the same, right? You can only subtract fractions when the bottoms are the same. So what are we going to do?
Times 2. First one by 2.
Times 2 top and bottom. That'll make the bottom 6. The other one already has a denominator 6. Right? That'll make common denominator. So that'll be what? 4 cube root 2 over 6 minus 3 cube root 2 over 6.
Cube root over 2.
So 4 cube roots of 2. Take away 3 cube roots of 2 is 1 cube root of 2 all over 6. And you don't need that 1 in the top, huh? That's cube root 2 over 6. Questions, we good? Same rules, isn't it? We just keep doing those rules over and over and over and over again, but it takes practice. All right. All right, so I'm going to multiply now. This is distribution. So now we're multiplying square roots. Here we go. This guy's going to go boom, and then he's going to go boom.
That's a 6y or 64?
Yeah, 6y. It does kind of look like it. My 4s look a lot like that, don't they? Those are y's. Okay, so here we go. So the first one's going to multiply, be root of 36y. Second one multiplies root of 6y squared. We're going to do a little more simplifying, but is that good so far? So I just simply multiplied them. 6y times 6 is 36y, and 6y times y is 6y squared. Good so far? That's just simple multiplication, huh? Now, can you break them down and ship them out again?
Yes. This 36, so you can do 6.
Yeah, what's the square root of 36? It's just 6. And the y has to stay inside. And the other one, you can break down the 6 if you want, but nothing good's going to happen. 2 times 3, so there's no pairs there. So I'm just going to forget that ever happened. But what about y squared? 2 y's in, 1 y out. What's left over inside? Just the 6. So I get 6 root of y minus y root of 6. Good so far? Can I subtract those? No. They're unlike. They have the same pieces, but they're in different spots, right? This is a root y kind of term, and this is a root 6 kind of term. We can't subtract those. That's it, we're done. We simplified them as much as we could. Yeah?
Is there a way to go backwards, so like from the answer back
to check? Yeah, not easily on this one.
I didn't think so, but I was just
Yeah, not easily. Yeah, no. Yeah, not an easy way to check.
okay.
Yeah. All right, let's try 14. Cube root of a plus 2. Cube root of a plus 7. Okay. 14. Cube root of a, wait, I lost it already. Cube root of a plus 2, cube root of a plus 7. Okay. Cube root of a plus 2. Cube root of a plus 7. Okay, so we're supposed to FOIL out. Now we got a cube rooter going on. So how does it work? So insiders with insiders, outsiders with outsiders, right? That's the rules for roots. Inside stuff multiplies inside stuff, outside with outside. Good, that's the rule we keep straight here. So here we go. So the cube root of 3 is going to go boom, boom. It's a FOIL, right? First goes to both, and when he's done, second guy will go to both. So first to both, cube root of a, what's that? Well, it's cube root of a squared. A times a, they multiply inside the root. Plus 7. You understand those 3's are in the hook, aren't they? They're not big 3's in the front. Right? They're in the hook. I made them maybe a little too big, but so he's done. He went to both, didn't he? The inside A multiplied the inside A, and then this. Notice the 7 went to the front. It didn't go inside because he's an outsider. Right? Outsiders stay outside. Insiders stay inside. Okay. Now the 2's going to go. He's an outsider. He's going to go boom. So he'll stay outside, and then 2 times 7, 14. Good so far? The multiplying's over at this point. The parentheses are gone. Now we shift gears into adding, subtracting. So adding, subtracting, you're looking for like terms. Hey, can I ship these A's out? There's 2 A's there? No. That's a 3 in the hook. He said, give me 3 A's, and you can take 1 out. We don't got 3 A's, so not going to happen. But right in the middle, these 2 are like terms, aren't they? So that's going to make 9 of those. So cube root of a squared plus 9, cube root of a plus 14, and we're done. That's as much combining as we can do. The only 2 that are like terms are the middle 2, aren't they?
That's like a ABC?
Yeah. So that makes sense. These 2, the letter pattern is the same on these 2.
Yeah.
So 7 and 2 makes 9 of those. But this letter pattern is different, and that's just a plain number. So we can't combine anything else. Good? What is like root 7 times square root 7?
49.
Square root 49, sure. And then what's square root of 49? 7. So two root 7s end up making a 1 plain outside 7. Of course they do, because 2 7s in, 1 7 out. So you can skip the root 49 step and just jump right to the 7 out, right? Because there's nothing in these hooks, which means 2 7s in, 1 7 out. What's a root 5 going to end up being? 1 plain 5, because 2 5s in, 1 5 out, right? What's root 11 going to end up being? 1, right? Get the idea? So anytime you multiply 2 of the same root, just 1 out. Save some time. So when you start this FOIL here, boom and boom, Root 6 times 3 root 6. See how you have root 6 and root 6? What are they going to do? One plain 6 will come out and hit that 3 that's already out to be 18 in a minute. Is that too fast? So root 6 multiplied 3 root 6. And this 6 and this 6 are both insiders. 2 6s in sends 1 6 out to meet the 3 that's already out there. Good, so I can write it down here. Root 6 times 3 root 6 equaled 3 root 6, 6, right? The 2 6s were inside, right? This one and this one. And then 2 6s in sent 1 6 out, right? Sent the 6 out, and they're gone. 3 times 6, going to be 18. You can make it 18 right now or do it in a minute. It's eventually going to be 18. Everybody good there? So remember, 2 whatever's in sends 1 out. Keep going on the FOIL here. Now the root 6 is going to go to the 1. Root 6 times 1 is just root 6. He's done. First to both, second to both. Is that a negative? What was that? That was a negative. So I'm kind of covering up the sign there. So now let the negative 3 root 2 go to both. And remember, outside stuff multiplies outside stuff. Inside stuff multiplies inside stuff. Minus 9 root 12, huh? 2 times 6. Insider with insider. We good there? Minus 3 root 2 times 1 is 3 root 2. Everybody good so far? See what's happening there? So outsiders with outsiders, insiders with insiders. And if there's ever 2 of the same inside, 1 comes out. That's how they get out of the root. That's the only way they get out of the root. 2 of the same, right? Like 2 6s inside made 1 6 outside, right here. 2 6s inside made 1 6 outside, didn't it? Good. And now, what now? Let me see. So plus root 6 minus 9 root 12 minus... Are we just done?
Common denominator?
There's no fractions here. Is there anything we can break down and possibly ship out? The 12, huh? The 12. So let's break down the 12. 4 times 3. 2 times 2. So what's going out?
2.
Yeah, 2 2's in. 1 2 out. It's going to multiply that 9 that's already on the outside there. So we'll get 18 plus root 6. So 2 times 9 on the outside is 18. It's supposed to be minus, huh? What's left inside? 3. Can we combine any of those? No, that's just it. That's an ugly answer, huh? None of those are like. None of those have the same roots. They're just like different letters. They're just different roots. They're all unlike roots. So how are we doing? Outside stuff. So when you multiply these things, outsiders multiply outsiders, insiders multiply insiders, and if there's 2 of the same insider, like root 6, that makes 1 outsider, doesn't it? Because 2 in, 1 out. And the 3 that was already out there is there, and that made the 18. Good? Questions? So that's really important. We'll use that a bunch on Wednesday. Let's try one thing. FOIL it out. First to both, second to both, 4 multiplications. And if you ever have 2 of the same thing inside, that's how they get outside. At least when there's a 2 in the hook, which there is. So here we go. So root 5x, what's that going to do?
5x out.
Plain 5x, because that's 2 of the same thing inside, huh? And then root 5x times root 6, they'll just multiply inside to be 30x inside. He's done, huh? First to both. His turn's over. And now second to both. That'll be minus root 35x, right? The 7 and the 5x multiply inside. Minus, or plus, root 42, because two negatives multiply to be positive. 6 times 7, 42. And that's it. There's just nothing more you can do. Those are unlike. You could try breaking those down. Nothing's going to break down.
But, Mr. Aaron, you have to put the little house all the way to cover both terms, right?
Yes. Yeah. This root goes all the way over both, and this root goes all the way over both.
If you don't do it like that, and the program...
It'll mess up. Yeah, because it's really important to know that all of that's inside the root, not outside. Exactly. Good. You're exactly right. Yeah, and if you broke them down, nothing's going to break down on that one. All right, let's see. 18. So cube root x plus 1. Cube root x minus 3 root x. Oh, that's a bad one. Ooh, wait. Okay. So here we go. So, all right. So this one is pretty tricky. Notice. Well, my writing's not the best either. Let me write better. This 3 and this 3 are in the hook, but that 3's in the front. See the difference? I'm not writing it well enough. Let me make this a little bigger. There. See the difference? So this, how about this? How about if I added a little 2 here? There's an invisible 2 there on that one. How about that? That'd be extra clear. Make sense? So they're trying to deceive you here. They're putting a couple 3's in hooks and then another 3 in the front. All right, so here we go. Let's carry it out. So it's a big old multiplication. So here we go. Cube root x multiplies cube root x. What's that going to be? Cube root of x squared. Insider multiplies insider, right? Minus 3. Now, what's going to happen with cube root x multiplying square root x?
You're going to add, no? The rules they add.
They say to add?
I don't know. I think they add.
Make a strong statement. I don't know. Any thoughts?
Subtract.
Yeah, it's hard.
Should take them out.
Yeah. Okay, let me tell you what it is, and then let me see. I'm not going to put this on the test. I can't change the homework at this point. It won't let me change. How about this? I won't count it against you. Don't worry about 18 and 19. I'll show you what it is, though, out of interest's sake. Mm-hmm. So what would be the cube root of x? Whoops, let me write it a little more neatly first up. Cube root of x times the square root of x. Because that's what's happening, right? Cube root of x, square root of x, and then a 3 in the front. Well, you'd have to change to fractional powers to see it. So that's why I'm not going to. Don't worry about it. But here it is. That's 1/3 power. That's 1/2 power. Remember? Remember how to change between fractional powers and roots? Remember the 3 could swing back in the hook. The 2 could go back in the hook. Remember that? So if you do that, and the 3's still there. Yeah, now how do you, what's the rule like if you have, I don't know, x to the 7, x to the 10? What do? You add those, right? Mm-hmm. Add those. So I need to add those. 1/3 plus 1/2, right?
Yeah.
So what do? Common denominator. See how tricky that is? So you have to multiply top and bottom of this one by 2, top and bottom of that one by 3. So that becomes x to the 2, 6, plus 3, 6. That's 5, 6. All that. See how tricky that is? So forget about it. I'm not going to put that. So don't worry about the homework. Just let those 2 go. I won't count it against you in your overall. I can't change it. Math Excel won't let me change it once anybody's worked on it. I'm sure somebody started it, and once they have it, won't let me alter the assignment. So I can't change it. But just forget about 18 and 19. Just skip them. Even though your homework will say it's less than 100%, I won't count it against you in the end. Don't worry about those 2. I meant to remove them. They're unreasonably hard. So we'll skip those two. All right.